Hello everyone. So this is a video on delta Y transformation. Delta Y transformation sounds scary, but it's actually really easy. So here you have two circuits. Now, these are all parts of the circuits. Remember what I told you about these round connectors? They denote part of the circuit. So this is literally an excerpt from a circuit. So what you have over here is three nodes connected together in a triangle. It resembles Greek letter delta, which is why it's called the delta Y transformation, because this one's delta and this one looks like Y. Okay? Now, I know that you're not used to looking at things in triangles, so this is what it would look like if it's all squared up. If it's squared up, it's called pi t transformation. So what is the main point of this? The main point of this is that it turns out you can turn this into that. In other words, you can turn any delta into y and any y into delta and vice versa. Okay, so it's very simple. Now how do we do this? Well, there are certain formulas that we need to use to do that. All of those formulas are derived from resistors in parallel and resistors in series, but I have a sneaky suspicion that most of you will fall asleep if I explain to you where the formulas come from. And I don't really care much about that, so I'm just gonna explain how this works, and then I'm gonna give you an example on how to apply this. The very first thing I need to do before I explain to you how this works is I need to carefully label all of my nodes. So this one's going to be node X, this one's going to be node Y, and this one's going to be node Z. And the same is true for this one, X, Y, Z. Now, those nodes will not change, okay? You will change the stuff inside the nodes, namely you will turn the triangle into the Y, but you will not change anything outside those nodes, okay? Please notice that when we turn the triangle into the Y, we're gonna add a node. Over here, right? This node doesn't exist in the triangle. All right. Now that I have labeled my nodes, I'm going to go ahead and I'm going to label my resistors themselves. So I'm going to call this one resistor A, or A. I'm going to call this one resistor B, or B. And I'm going to call this one resistor C. And so that we don't get super confused, I'm going to use numbers for my Y. This is going to be R1. This is going to be R2. And this is going to be R3. Okay. So what I'm going to do is I'm going to take out the triangle, for example, and replace it with the Y shape. Now, when I replace with the Y shape, my resistors R1, R2, and R3, their values have to be in terms of RA, RB, and RC so that we can actually do our calculations. So when you're going from delta to Y, these are the formulas. So this is delta to Y. So what is going to happen? When you replace this configuration with the Y, the value of R1 is going to be this expression. So you literally plug in the numbers and calculate what it is. The value of R2 is going to be this expression. You literally plug in the numbers and calculate what it is. And then the R3 is this expression. Once again, you plug in the numbers and you calculate what it is. Now, do you need to memorize this? No. Okay. However, there is a nice trick to remembering this one, take a look where your R1 is. Your R1 is right in between RB and RC if I were to draw it there. Make sense? So RB and RC multiply together and go on top. The bottom is always RA plus RB plus RC. So the top for each resistor that you're plugging in is always the two that it would be in between. Here, let me show you what I mean. So here's a nice enlarged version of my delta, right? Now remember, Y goes from all those nodes, but it's the Y inside the delta. So I'm going to go ahead and draw my Y. And I'm going to draw my Y in red. So I'm going to start from this node. I'm going to have a resistor over here. I'm going to have a node in the middle, like this. I'm going to have a resistor go into the Y terminal, and then I'm going to have the third resistor going into Z. Okay, you guys see this? Okay, remember my formulas, right? How I had R1 is RB, RC on top over RA plus RB plus RC. Well, this is R1. How do I know it's in between RB and RC? This is my R1. So whichever one is you're looking for, right? It's going to be multiply the two next to it over the sum of all three. So looking at this, you should think that, okay, R2 has to be RA times RC. Well, let's take a look. And R2 is RA times RC. So it's always the one in between. This is my R2. And my R3 is RA times RB over the sum. Right? So very easy way to remember this transformation, really. Okay. So I showed you the transformation. Right now you should be completely bewildered because you'd be like, but why do I need this? Well, let's do an example. Yeah. Let's take a look at this circuit. There is absolutely nothing in series or in parallel in here. Just look at it. It's absolutely messed up, right? We don't even have a starting point. Remember last time we were doing series and parallel simplification, right? And we always had some kind of starting point. We turned series into parallel, or we got rid of the parallel configurations. We ended up with a series. We don't have a starting point. This is a total loss unless we can do a delta Y transformation. Now, at this point, you should be saying, oh, but miss, there are no triangles here? Sure there are. You can rearrange this into a triangle very easily. I claim that this is exactly the same configuration. Now, you obviously see that I drew this on a touch screen, so it doesn't look very pretty, but it's still the same thing, okay? And how do I know it's the same thing? Well, you know, guys, it doesn't really matter how you bend your wire. Like I told you multiple times, this is still the same thing. So this is still R2. This one is R3. And R1 is still the one in between, right? So this one is R4. And this one is R5. Well, here's the deal. We don't have a starting point for this circuit except one thing, the delta Y transformation. So what I'm going to do is I'm going to turn one of those triangles into a Y. So what I want to do is I want to turn the bottom triangle, R1, R4, and R5. I'm going to turn this into a Y. So instead, I'm going to put in a Y in there. And once I do this, I'm actually going to end up with two resistors in series on this side, two resistors in series on this side. So I'm going to have two. Those two will be parallel branches, and then I'm actually going to have a circuit that I want. Once I do the substitution, and let's call this one RA, and this one RB, and this one RC. Once I do the substitution, my circuit is going to be solvable. So let's take a look what it's going to look like once I do the substitution. Once I do the substitution, I end up with something like this. Now, this is very poorly drawn, but you guys can see what I'm getting here. And if you notice, this place has only two nodes, one over here and one over here. That means that these two are going to be in series, and these two are going to be in series. That's perfect, right? I can simplify this, then I have obviously clearly two parallel branches, and I can finish solving the circuit. But before I do this, I need to know what is RA, RB, and RC. So all I need to do is plug in the formulas. There is really nothing more to it. So let me plug in my formulas. So first, let's find my RA. So RA is this one. It's in between R1 and R4. Now you guys remember what I told you about being in between? That means R4 and R1 go on top. So R1 times R4 divided by R1, R4, R1 plus R4 plus R5. So that's my formula for RA. Okay, let's plug it in. Everything is 1K. That's going to be a nasty calculation. I should have chosen an easier number, right? So I have, well, 1K times 1K is 10 to the 3 times 10 to the 3. That's 1 meg, right? So I have 1K ohm times 1K ohm and divided by 3K ohm. All right, that makes sense. So the ones on top is 1 mega ohm, right? But my top and bottom is going to cancel out. One of my K's is going to cancel out, so I can just do that. So let's say this K ohm and this K ohm will cancel. So I'm just going to have 1/3 K ohm. Okay. Well, let's see what that is. So this equals to 1/3, and this is K ohms. And 1/3 is 0.33333. Guys, as always, I keep 3 sig figs, so it's 333 ohms, right? Because I am I'm using up my K, right? So I end up with 333 ohms. All right, very, very simple. Well, what about RB and RC? Well, they're actually going to be exactly the same value because all of my R's are the same, right? But for the sake of the argument, I'm going to write down the formula. So here's my RB. And my RB is right in between R1 and R5. So it's R1 and R5 who's going to go on top.